starting to record. So I will be sharing my screen, showing you stuff in snow and also some slides in order to give more context to my discourse. And after that, we will host a questions and answer. So the public question and answer will last 5 to 10 minutes, depending on the participation. And for the following 30 minutes, I will remain available if anybody has questions regarding the stuff we will have covered. I will answer these questions privately, either through email or through this GoToMeeting session that is running right now. So let's hit it and get started already, okay? Oh yes, one thing I should mention right now is that, as I mentioned, we are recording this webinar. So if you manage to lose your connection to the session or have to walk away for any reason, don't fret. We are recording. The recording will be put on our website a few hours after the diffusion so that you can go and download it for delayed viewing at your leisure. Okay, so we're talking about ways in order to elevate privileges on the Linux platform, and the discussion today will also be of use for anybody who's worried about privilege elevation on other Unix platforms. Basically, whenever you're worried with privilege elevation on Unix, there are basically two paths that you should be looking at for elevating privileges. The first such path is a kernel exploit. Oh, give me just a second here. Okay. The first such path is a kernel exploit. Okay, in a sense, your attacker will attempt to gain execution in the kernel by hacking some user mode interface to a kernel service. Okay, so once that hacker has gained execution in the kernel, his goal will be to grant root privileges to a running shell or backdoor process through poking in the kernel's data structures. That's fortunately very easy to detect. Okay, so once this has happened, we just have to have a scanner of all running processes and to take a look at their user IDs. Whenever the user ID of a running process changes by decreasing, thereby suggesting that the process is increasing its own privileges, it goes against a golden rule of the Unix security model, which is that privileges for a given process can be reduced but can never be augmented. So that's pretty easy to detect. That flashes as a big red light on our dashboards, and there is little that a hacker can do in this space that will go beyond our surveillance. The alternative from exploiting the kernel is to hack a highly privileged user mode application. So in this case, you want to gain execution in some daemon, either through a good old memory exploit or more generally by exploiting a fault in the way this daemon handles its input, or a fault in the protocol for handling inputs, either from the design or the implementation. As an alternative on Unix, you can hack the input parameters to a setuid program. So a setuid program is basically the tool of the devil. It's, on the other hand, the only way for a user mode program to go from an unprivileged program to a high privileged program. So in a sense, setuid programs, when they are started, get the privileges of the owner of the program rather than inherit the privileges of the parent process. Okay, so this means that if a setuid program belongs to root, when you run it, this program runs as root. Okay, even if it was run by good old me who is not root. Okay, so these things are evil. Okay, it's the only way to properly implement the normal privilege elevation programs such as SU or pseudo, but many systems administrators are hell-bent on having on delegating certain systems management tasks using setuid program, and this is a very, very bad idea, and most privilege elevations go through these setuid programs. So what you do when you are hacking a privileged user mode application, essentially you coax it into forking a shell or a backdoor for you, right? And this is hard to detect, surprisingly. Why? It's not so much that it is difficult to detect whenever a certain program forks a child process that suddenly has a higher level of privileges. It's just that this pattern of events is frequent, right? Many high privileged applications will fork into high privileged child processes on a regular basis, thereby granting many false positives to any test checking that. So, what do you do in this case? Well, all the legit stuff you try to whitelist, right? So you will inspect, you will audit your typical privilege elevation pathways on a system, but you will only whitelist them at your own peril, as the upcoming examples are about to show. Okay, so two examples here. One is about a situation where we get the sense of a privilege elevation, but there is none, and the other is an actual good old privilege elevation problem. Okay, so let's take a look first at this investigation here. Okay, so what we have here, let me augment, oh, this is too much. Okay, so what we have here is this process called Polkit Agent Helper 1, which is now running as root, but has a parent that was Polkit GNOME Authentication Agent 1 that was running as user Victor. So user Victor was able to fork a new process called Polkit Agent Helper 1 from Polkit GNOME Authentication Agent 1. So what's at stake here? Well, when you're in the know as to how the GNOME interface systems work, you quickly learn that GNOME has its own wrapper around the pseudo process. This wrapper basically handles the authentication checking, and then once the identity of the user has been checked and been known to match the set of users who can run sudo, then it has its own setuid helper process, in this case called Polkit Agent Helper 1, in order to get it to elevate privileges on a running GNOME process. So when you go and look at when you go and look at what is happening here, right? So this is the raw data stream sent by the machine on which this elevated process was found to run. And when you go into the passed for this, you see that the user was running apt likely through the systems update tools enabled by his Ubuntu machine. So when you're running apt and you call for a system update, then of course you need to elevate your privileges in order to get this updated system. So this is what happens here, and after that, the system starts downloading new packages, and if we keep digging down and exclude everything that's concerned with Chrome, we see that stuff start deleting an old version of libc, and then it starts decompressing and unarchiving new new packages, in this case apparently Go 1.8.Linux AMD64, and we see other traces through new processes that talk about the update of the system. So in this case, in this investigation, it is clear that the process elevation from the GNOME authentication agent, when the when the high privilege process created is Polkit agent helper 1, this is clearly a legitimate setuid process granting legitimate privilege elevation. All right, onwards to our next example. Here, we have an investigation where the essential label is that privileged process ifstat with unprivileged parent bash. Okay, let's take a look at this guy. All right, so here we have a process in path user local bin ifstat that's been started by a good old shell from user Hamelin. Hamelin, yes, that was me. Yeah, I did prepare for this. It doesn't look like it, but I did prepare for this. In any case, this process is running as root. So, what can we expect from this? What is the smell that I get? Well, clearly, this program ifstat has been put into user local bin. Typically, people deploy programs in that directory when it's programs that are not managed through the system's packaging system, right? So this means that likely this ifstat program is a homegrown piece of software or something built and put there through a hand-managed package. Okay, so I go through to the systems administrator and ask, okay, what is ifstat? And as the systems administrator, I say, it is a wrapper around ifconfig. So the ifconfig program, for context, is one by which you can query and modify the network configuration for a machine. And so, me again, as systems administrator, tell you, it's because I wanted ifconfig to only be runnable by root. And so I have written this wrapper around ifconfig called ifstat to enable users to use ifconfig only to query the status of network interfaces. Ah, says I. That is interesting. So how do you manage to get it to run ifconfig if your wrapper is meant to be run by lowly unprivileged users? And me, as a systems administrator, say, I have configured it as a setuid program. And then me as a hunter say to me as systems administrator, you are a fool because look what this user has done to you. It has called your ifstat tool in order to query the status of the ETH0 interface. Up to now, that's fine. But then what do you see? You see the typical signature of somebody hacking the inputs of a setuid program. In this case, the user has managed to introduce the possible invocation of a shell. So basically, the inputs to this program is probably fed into the system libc function, which starts a shell in order to run a child program. And when you do so and do not properly sanitize the inputs that you set up to be run by system, then you run the risk of your user putting in inputs that do way more than you intended to do with your wrapper. So let's dig down a little from there in order to figure out whether the user actually managed to elevate his privileges in this instance. So the same way I did with the first instance, I go to the raw data stream for this machine around the instance of the detected privilege elevation. So clearly this has happened soon after starting the system. So I go down, I am looking for an invocation of the ifstat program. Okay, here it is, ifstat. Now this code identity piece of telemetry was about hashing this program. And then here I see it, I see a new process here where a process which was the parent was ifstat, okay, which we saw run from a shell initially. And now this program ifstat is launching a shell in order to run ifconfig eth0 followed by /bin/dash. This does not smell good because what happens after that? It runs this shell through ifconfig. It runs its shell, who then runs ifconfig, and after that starts a dash process. Dash is a shell on this system, and this dash process is indeed running as root. Okay, so there is indeed in this instance the actual elevation of a process through an illegitimate mechanism. All right, and this privilege elevation event requires immediate incident response because once this dash shell was launched, it had root privileges, so it was able to do everything on the system, including deploying a backdoor, including deploying a rootkit. All right, and this concludes my yada yadaing, and I opened the possibility for questions. Now, the way that this webinar is set up, you can't just ask a question with voice chat. You have to type it into the questions box at the bottom. So feel free to type away your question and I will be handling it for the next 10 minutes. Please don't be shy. I don't bite. I will not ridicule you. I've been taking my pills today. Okay, I got a question here. So I am being asked here that whether, so once the user has started his shell through, once the user has started his shell through the privilege elevation, Is there a way for the hunter to keep tracking what he's doing on this system? The answer is yes and no. So a shell on a system is basically a process itself, and every command line you input through a shell is basically consumed and interpreted by the shell itself, right? For instance, if you type the name of a program followed by its command line arguments, then the shell is parsing that command line in order to determine which program to run, right? And then forks a process and executes that program into the process. And so you are not able to track the parsing of the command lines being run in there. What you can track though through Snow is the starting up of new programs using that shell. Okay, so starting new programs generate information that Snow tracks and reports as telemetry through new process events, and then the end of such programs generate program termination events or something like that, no, terminated process. And in this case, you are able to easily follow which you are able to easily follow what the user is trying to do with his shell. But if what he does with his shell is a shell program, like it's running echo statements or it's running statements that involve built-in constructs of his shell, then you are blind to these. One trick that we have discovered while investigating a similar event in the recent past was that an attacker was passing the program he wanted to run in his shell through the shell's standard input. So what we did in order to capture the program and get a better sense of what the attacker was doing is we replaced the dash process with a shell script that did run from dash, and that shell script would first take a copy of everything that was sent on standard input into a file before feeding it to the real dash process. So that way we could capture the program. But whatever happens within the dash process, we are blind to it. All right. Any other question? All right. So some people are suggesting they will send me questions in private. No problem. I will answer those at any moment. One question I'm getting. One question I'm getting here, sorry, is about privilege elevation through kernel exploit, and I'm being asked if I can show an example of this. So I'll be completely frank with you. I did my best to replicate a privilege elevation process on one of my virtual machines all morning and was unable to do so because my privilege elevation process relied on a race condition. So I will be providing you guys with an addendum to this webinar by making a video, and I will send all participants a special link to easily download this video where we investigate the results of a privilege elevation from a kernel exploit. All right, another question right here. I'm being asked about the ifstat example again, and I'm being asked, okay, so you're saying that this ifstat program is a setuid process, or rather a setuid program that is insecure and that could easily be used in order to start a new shell from input programs. So could an auditor easily see that? Well, it's a good question. In this case, okay, I wrote ifstat by myself and I left a hole in it on purpose. So obviously, if I take a look at my own program, I see it instantly. Okay, so let's play a game. I will show you the program. Obviously, I had to lose it. Oh yes, I remember where I put it. I put it on this machine where I wrote it. Okay, so good. Okay, so here is the program. I will try and increase the size of the font a bit. Okay, so here is the whole wrapper around ifconfig. Can anybody tell me at a glance where the exploit can be found? So here we are checking that the only argument that can be used in order to send to ifconfig is one of the interfaces for this computer, which are the loopback interface and the ETH0 Ethernet interface. Okay, and how we do that? We check the first few characters, and then if those characters match the name of the interface, then we say we've found it. Okay, but then what do we do with it? We still use the whole argument, even though we have only inspected its first few characters, right? So there lies the vulnerability that I could exploit, right? Could anybody find that in a single glance? Maybe somebody who's used to auditing programs for such vulnerabilities. But otherwise, I don't believe that for anybody who is not intimately familiar with the C language and its intricacies can find that in a single glance. So I remain by my my message from the beginning. All setuid programs are suspect. They're a tool of the devil. Hackers will first try to get into your Linux systems through your setuid programs, so have as little of those as you can. Don't make setuid programs for the sole purpose of masquerading certain interfaces or for delegating systems administration tasks. There's other much better ways than making setuid programs. Any other question? So we're past 1:30. Let's put an end to this webinar. I will remain online with my audio cut into this webinar so that if you want to send me private questions, I can answer them right here. You can also write me an email at the address being shown on your screen right now. And all that said, I thank you very much for your attention, and we'll get to make another show like this in about a month. Thank you very much. Cheers and goodbye.